Okay, so let's look at number 9. And number 9 deals with finding the domain and range of a function or a line. Okay. So when we're talking about the domain, we're talking about the x values. It's nothing fancy. The domain is just talking about the x values. The range is talking about the y values. Okay. So if we're looking for what represents the domain of this function, we also want to focus on the dots right there. If we have a closed dot or a dot that is filled in, we would include the number for x. So we would use the inequalities less than or equal to or greater than or equal to. If we have an open circle, we would use these inequalities that do not include the number. So if we're focused on the domain, let's look at the value of x that it reaches, which in this case would be -6, and on the other side, -8. So we could write it as -6 is less than or equal to x, but x is less than or equal to 8. Or sorry, not, since this is an open circle, we would use this inequality. It is less than, but not equal to. So we could say that C would be our answer. It says that all real numbers are greater than all real numbers are greater than or equal to 6, but are less than 8. So let's look at this next one. Now, the difference between a continuous function and a discrete function would be that a discrete function just uses points like this one does. A continuous function would connect all these points and make a line. So automatically we can say that the answer cannot be h or j because this is not a continuous function. Now we're looking for what the domain of the function is. So the domain would be talking about our x values right here. So our domain would be our x values. So we can say that our domain is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our only possible answer would be F.